All right, today we are diving deep into the secret rulebook that pretty much runs the internet. It's something that's working behind the scenes every single time you go online, the OSI model. So let's jump right in. Think about it. You type a message, you click a link, you send an email. It just works, right? It feels instantaneous. But in that tiny split second, your data goes on this incredible multi-stage journey. And that journey, well, it follows a very specific set of rules. But it wasn't always so organized. In the early days of networking, it was pretty much the Wild West. Total chaos. See, every company had its own unique proprietary way for sending data. So if a network from one company tried to talk to a network from another, well, they might as well have been speaking completely different languages. As you can imagine, troubleshooting was an absolute nightmare. This lack of a common standard was a huge problem. So to tame this networking Wild West, the International Organization for Standardization came up with a universal standard way back in 1984. It was designed to bring order to all that chaos, a common framework that any system, anywhere, could use to communicate. And this is it, the Open Systems Interconnection Model, or what everyone just calls the OSI model. The easiest way to think about it is like a 7-story building. For your data to get from your computer to its destination, it has to start at the top floor, travel all the way down to the bottom, and then go all the way back up again on the other side. So how about we follow a little piece of data on its great escape? We're going to start right at the very top, where you, the user, kick the whole thing off. We're going to trace the path of your data, starting from the application you're using right now, and follow it all the way down through these layers until it's nothing more than a pulse of light or a blip of electricity. So we start at the very top, layer 7, the application layer. Now to be clear, this isn't your web browser itself, but it's the protocols that allow your browser to talk to the network. We're talking about things like HTTPS for secure browsing or DNS, which looks up website addresses. This layer is basically your direct window to the network. Next up, your data hits layer 6, the presentation layer. You can think of this as the universal translator. Its job is to make sure the data from your application is in a format that the receiving computer can actually understand. This is also where really important stuff like encryption and data compression happen. It's all about getting your info neatly packaged and ready for its trip. Moving down to layer 5, we get to the session layer. I like to call this one the conversation manager. It's in charge of opening, maintaining, and eventually closing the communication channel between two devices. You know when a big download gets interrupted? Well, it's the session layer that lets you resume it right where you left off. Pretty cool, huh? Okay, so our data is all formatted and the conversation is officially open. Now we've got to get it ready for shipping. It's got to need an address, and it needs a reliable way to get where it's going. This brings us to the absolutely crucial transport layer, layer 4. Think of it like a postal service that gives you two very different delivery options. First, you've got TCP, the reliable messenger. It breaks your data into numbered pieces, or segments, and checks to make sure every single one arrives in the right order. Then you have UDP, the speedy messenger. It just sends everything as fast as it can. It's perfect for things like video streaming, where getting the data there quickly is way more important than catching every single dropped frame. Down we go to layer 3, the network layer. This is basically the network's GPS system. Here, our data segment gets wrapped up and becomes what's known as a packet. And most importantly, this is where the long-distance address gets slapped on, the source and destination IP addresses. This is what routers use to figure out how to get your data out of your local network and send it soaring across the globe. Now that IP address is great for getting the packet to the right network, but it doesn't get it to the specific device. For that final step, we need layer 2, the data link layer. It takes that packet, wraps it in something called a frame, and adds the local hardware address, the MAC address. This is what lets a network switch deliver the data to the correct computer right there on your local network. So, at this point, our data is fully packaged. It's got an address for its long-distance journey and one for its local delivery. There's only one step left, turning all of that digital information into something that can actually physically travel. And here we are, the final stop on the way out. Layer 1, the physical layer. This is where all the data we've so carefully packaged gets converted into ones and zeros and then into an actual physical signal. An electrical pulse in a copper wire, a flash of light in a fiber optic cable, or a radio wave sent right through the air. And once that signal reaches its destination, the receiving computer does this whole process, but completely in reverse. It takes the physical signal, turns it back into frames, then packets, then segments, and it just keeps unwrapping it layer by layer until the original data appears perfectly translated, right there on the recipient's screen. It's a truly elegant system when you think about it. Now, after all of that, I have to tell you there's a bit of a twist. While the OSI model is the universal way we talk about networking, it's not actually what the modern internet is built on. You could say it's the map, not the territory itself. So let's take one last look at this 7-layer map. You've got the application services at the top, handling what you see, all the way down to the physical bits at the bottom. Each layer has a distinct and vital job. And this structure, this is the key to understanding how networks work and, probably more importantly, how to fix them when they break. And that really brings us to the most important takeaway. This quote says it all perfectly. The OSI model is our common language, it's our diagnostic framework, it's the beautiful theoretical ideal of how things should work. But in the real world, the internet actually runs on a more streamlined 4-layer model called TCP/IP. You can see it basically combines the top 3 OSI layers into a single application layer, and it squishes the bottom 2 into a network access layer. It's just a more practical way to do things, but it was built on the exact same fundamental ideas as the OSI model. Which leaves us with one final thought. If the OSI model is just a theoretical guide, why does every single network professional learn it inside and out? Well, because when your internet goes down, figuring out if the problem is a bad cable at layer 1, a wrong IP address at layer 3, or an application glitch at layer 7 is the absolute key to solving the puzzle. The map is what makes navigating the territory possible.